Hello, this is Chapter 3 review for chemistry. The big ideas of this chapter are atomic theory, atom composition, and stoichiometry. So Dalton's atomic theory. So all matter is composed of extremely small particles which are called atoms, and atoms of an element are identical in size, mass, and other properties. However, atoms of a different element differ in size, mass, and other properties. So, the atoms in a hydrogen differ than an atom of a carbon. So all elements combine in whole number ratios for chemical compounds. In chemical reactions, atoms are combined and separated or arranged. They are not created or destroyed. So the structure of the atom. The nucleus of an atom is composed of two types of particles, protons and neutrons. Protons are particles with a positive charge, while neutrons are a particle with a neutral. Protons are particles with a positive charge, and neutrons are a particle with a neutral charge. Electrons are in orbitals around the nucleus of the atom, and they have a negative charge. A good way to remember that is the pro and proton, the nu and neutrons for neutral, and the electrons will be left with the negative charge. Atomic number. So the atomic number of an element is the number of protons that the atom has. So all protons of an element have the same amount. All atoms of the same element have the same number of protons. So hydrogen has 3 isotopes, and in its 3 isotopes, they all have the same number of protons, but their number of neutrons differ. So that's what statement 3 says. So atoms with the same amount of protons but a different amount of neutrons are called isotopes. And the mass number of an element is the number of protons plus the number of neutrons. So average atomic mass. So the average atomic mass is a combination of the percent of the abundance of an isotope and the atomic mass of that isotope. So in the world, there is a certain combination of hydrogen isotopes, or all the isotopes, all the atoms. So we write them as an average instead of the two different masses that we would have here. So you would take the abundance of one. So you take the abundance of hydrogen, 1, and then you would multiply it by its atomic mass, which would be 1.007825, and then you would add the percent of abundance of hydrogen 2 times its atomic mass, and then you would get the average atomic mass of that element. So basic stoichiometry. So this allows us to go from different units of the amount of a substance, and later it will help us in chemical reactions, but right now we're using it to go between particles or atoms, molecules or friendly units, to moles, and to grams. So a couple things to note here is in order to get from moles to particles, we use Avogadro's number, which is 6.022 times 10 to the negative third. So 6.022 times 10 to the negative third atoms, molecules, or friendly units is equal to 1 mole. And then to get to mole, from moles to grams, we use molar conversions, and you'll see that on your periodic table, which you will get a number for example, hydrogen, have a molar conversion of 1.01 grams per mole. I can spell right. So it has a molar conversion of 1.0 grams per mole, and that's the molar conversion we'd use to get from moles to grams. Since a lot of people may struggle with stoichiometry and it comes back and it's really important in chemistry, I'm going to go over a couple of example problems. So our given is that we have 3.50 moles of carbon, and our unknown is the mass of carbon in grams. So for the first step of this, you want to set up your molar conversion. So you always want to start with your given over 1. So we're going to start with 3.50 moles of carbon over 1. And then we'd refer back to our periodic table to find the molar conversion of carbon, which is 12.01 grams per mole So it's 12.01 grams per 1 mole of carbon. And then we set up our equal signs, but before we do that, we check for unit cancellations. So the moles cancel here, and we're left with grams, which you want our final answer to be in. So I'm just gonna crunch the numbers real quick. And for an answer, we get 42.0. Yeah, 0.3 grams, and then we check for sig figs. I have too many, so that'd be 42.0 grams. Given for the next one is 11.9 grams of carbon dioxide, and we want to find the moles. So similar to this, we start with our given, which is 11.9 grams of carbon dioxide over 1. Since we're gonna have unit cancellations, we know we're gonna have grams here, and we want moles, so moles on the top. So again, we are going to look for a periodic table to find the mole conversion, but we have to add the molar masses of carbon and a peroxide. So that's 44.01 grams per 1 mole. You set up our equal sign and then always check for unit cancellations, and you're left in moles. So again, we're going to do the math. And then I'm getting an answer of 0.2703. And we have 3 sig figs in our answer. So our final answer to be 0.270 moles of carbon dioxide. And then for our last one is we're going from grams of sulfur to the number of atoms of sulfur. So this one's slightly different. We have 2 steps for this one. In the previous 2, we just had 2 different conversions. So again, as always, we want to start with our given over 1. So 13.50 grams of sulfur over 1. And a lot of people would make the mistake here and try to go directly from grams to atoms. However, we cannot do that. We must go to moles first. By following the mole map. If we're in grams, we cannot go directly to particles. we must go to moles and then particles. So then we set up our unit conversion. So there are 32.01 grams of sulfur in 1 mole of sulfur. And then we want to set up our unit conversion, which is Avogadro's number. So 1 mole is equal to 6.022 times 10 to the 23rd. That'll be in atoms. And always check for unit cancellation. So grams cancel, moles cancel, and we are left with atoms. I'm going to crunch some numbers, and I'm getting 2.5397 times 10 to the 23rd. For sig figs, it's a 2.540 times 10 to the 23rd atoms of sulfur. And that is all for chapter 3. I'll see you next time.